open. Come on, what's this taking so long? Computer not powerful enough. But I like it. It's old. It's strong. It's lasting a long time, you know. I must have this laptop now for maybe nearly. Not too far away from 10, I don't think. Maybe I had it like 8 years. I recently upgraded it. It was 1 gig, now I upgraded it to 2 gig. Whoa. High speed. Right, velocity time, if you can write that down. You got that, Ming? Velocity time. Guys, come on. We're continuing. You got that? Velocity time graphs?
Yes.
Yeah. Right. I don't think we'll get everything. Well, I don't know. We'll see. I don't think we'll get everything covered. We might. Let's have a look. So, some things to be clear of before we begin. In one dimension, positive usually means to the right, and negative means to the left. But you know this from maths class already. Vertically, positive means up, and vertically, negative means down. Now, is this a rule? No, it's not a rule. It's what's called a convention. Does anyone know the difference? It's not a rule, it's a convention. What does that mean?
Convention means everybody's saying we do that in this way.
Yeah.
It's not forced everyone.
Exactly, you're not forced to. Just most people do. So you could change this, and sometimes it's convenient to do that, but usually not. Okay? Right. So, a single real number could actually be a vector. For example, if I say s equals 1 meter, I mean 1 meter to the right. So there's a direction. But if I say s equals minus 1 meter, that means to the left. So can you understand that plus and minus is like the direction? So that makes it a vector, not a scalar. So scalars can only be positive, but if you have positive or negative, then all of a sudden you have a vector. Yeah? So you don't need to write all of this, but I would like you to make some notes of this page. Maybe write something you didn't know. If you knew all of this, then, I don't know, draw a picture or something. Okay. Continue. Yeah? Definitely don't write everything. There's too many words here and not a lot of information. I mean, what could you do for the first 4? You could draw a picture, couldn't you? You could just go plus, plus, minus, minus. Right? Okay, let's continue. So, next we need a definition, and I wonder if anyone knows this definition. Does anybody know the definition for acceleration? Do you know this word, acceleration?
Yeah.
Yeah?
The change rate of the velocity.
Yeah, yeah. Acceleration, firstly it's a vector, isn't it? And it's defined as, you said, Kehong, nearly perfect, rate of change of velocity per time. Okay? So as a formula, well, what would be the formula? Yeah, the change in velocity over the time taken. That's the acceleration. And what would be the units? Yeah. I never actually wrote the units down, but the units we can see, if I have a velocity and a time, that's meters per second per second. So that's meters per second squared. Okay? Alright, you'll need that definition. Now in the exam, when they ask you for the definition, you don't have to give the formula. So in the exam, you could just write this and you would get full marks. Okay? Okay. You got that? No. Well, I still see people writing. Okay, I'm not going anywhere.
Either right.
What's going on? What did I miss? Okay, whatever. See? Even you can make this mistake. Okay, continue? Yeah? So, we actually have some names to go through. This might be different depending on your country. So here, when we say use the letter U, what U means is what's called the velocity at the beginning, initial velocity. Yeah, now some people would come from countries where maybe they would have called this V0 or VA or V1 or something like this. Yeah, but here we say it's U. Okay. V is the velocity at the end, also called the final velocity. A, well, guess what A is? It's the acceleration. T, time. And lastly, S.
Speed.
No, because we have U and V. Not quite the distance. Displacement. Okay, I think you should write some notes on this. Yeah?
No.
Okay. Got it? I see two people writing. No, I see one person writing. Two people writing.
Just the one word.
Just one word? Okay. Okay, good. Let's continue. So, let's see. Yeah, so here's an example. Let's take Usain Bolt. You know him? So, let's look at this. Yeah? Let's look at this. So, for this race, what would be U? Mm-hmm. Yeah, but we know what it is. What's U? Yeah, 0. They usually start the race at rest, don't they?
Yes.
Yeah. What would you say, roughly speaking, is the v, the speed at the end, the velocity at the end?
9 maximum.
No. What is it? Yeah, but give me a number. Roughly, what do you think? Is it 100 meters per second? No. So
10.
be over 10. Be over 10. In fact, I think it's about 14 meters per second at the end.
Maybe 50.
Maybe even 15. Okay. The A, I don't know what the A is. It's the acceleration. It could be 2 meters per second squared. I don't know. The T, we know. What's the T?
9.
Yeah, that's it. 9.6, isn't it? 9.6 seconds. And the S, we definitely know 100 meters. Right? So, remember, velocity can be positive or negative because it's a vector. But speed is only positive. Also, displacement can be positive or negative because it's a position. But, what do you think we want to say next?
Distance.
Distance can only be positive. Yeah? Do not confuse speed and velocity or distance and displacement. However, usually they are the same in the question. Like in the example of Usain Bolt. The displacement was 100 and the distance he travelled was also 100. His speed was 14 and his velocity was 14. Okay? They're usually the same thing, but they're not always. Alright? Now, if you want to write something, you can, but I mean, it's a warning and it's in red, so remember this. The message is be careful with your plus and minus. That's the message. Okay. Oh no, don't write the whole thing, that's way too much. You can write a note, be careful with plus and minus. Alright. Continuing.
Wait a second.
Ah no, son, no, it's too much here. You're going to write the whole thing?
Yeah.
Ah, you can get it from the YouTube video later.
Okay.
Just leave a space.
Okay.
Alright, you've been warned. Now, here is an example of what's called a velocity-time graph. On the x-axis is time, and on the y-axis is velocity. What I'd like to talk about is what is happening in this story. So let's imagine that this is a car. So what does the car do for this part of the journey? As the time goes by, what's happening to its velocity? Increasing. Quickly or slowly? Slowly. So the car is slowly accelerating. Then what suddenly happens here? Yep, I would say it enters a motorway, highway. Yeah. Then what is happening here? Yeah, why? Yeah, or speed limit. Speed limit. Maybe. Yeah, speed limit. But now what happens?
Stops in front of you.
What happens? Slows down quickly. And there's an accident. There's an accident up ahead. Yeah? Now, here what's happening? Stop. And now here, reverse back out the highway at a constant speed. Now, do you notice how that this is shorter than this? Like this is nearer to the zero. Well, this is normal, isn't it? Cars don't usually reverse as fast as they can drive forward, right? Right? Like maybe a car can go 120 forward, but 20 or 30 backwards. You know? All this vocabulary is useful. This is accelerate slowly, accelerates quickly, steady speed. rapid deceleration, opposite direction, steady speed. Okay? This is accelerating. This here, decelerating. What's another word for steady speed?
Constant.
Constant speed. What's another word?
Zero acceleration.
Oh, one word. You're right, zero acceleration or uniform velocity, yeah. I would like everyone to draw this in their notebook, please. What's going on? What's going on? Are you up to trouble?
No, it's like drawing the line. It breaks the paper.
I see.
Okay, you drawn that, Joe? You got that drawn? Yeah? Now, next. So, here we have a car starts from rest. It slowly accelerates to 20 in 10 seconds. It then maintains this speed for 5 seconds and then suddenly decelerates to rest in 4 seconds. I want all of you to draw the graph. Don't forget to include the numbers and the name, time and velocity. Okay? I'll draw it in a minute. Let me see you draw it first. got that? Will we have a look at it? Yep. So, I should hope you have this. There's the time in seconds. And here is the velocity in meters per second. And we start at 0, and then we reach, is it 10? 20 here. And this here is 10. And then we travel constant for how long? To 15, correct. Oh my nose, sorry. And then suddenly decelerate and finish at 19 then. Okay? Easy peasy? It's fine. So, you would remember these well, maybe not. Maybe you didn't do this. If you'd seen this triangle in school, distance, speed, time. So if you want distance, that's equal to speed multiply time. If you want time, that's distance over speed. And if you want speed, that's distance over time. Yeah? So, this triangle here, we can just write it as one triangle. Oh. This is distance, speed, time. But you need to be careful. There's a little warning here. This triangle only works when acceleration is 0. So if you don't have any acceleration, you can use this triangle to calculate distance, speed, or time. Okay? But still, that's actually still very useful. So I just want you to copy this triangle. Distance, speed, time triangle. Just add this to your notes. Got that? Yep. Okay. A boy walks 2 kilometers to school every morning. It takes him 30 minutes. What is his speed? Okay, I'll just give you a few seconds here. Give me his speed in kilometers per hour. So use the triangle. What's the formula for speed? Distance over time.
15.
No.
4.
4 kilometers per hour. Yeah? Okay. Right, you might be thinking that velocity time graph can tell us the velocity. And that's right. However, it can tell us much more. Let's see. So if you look at the velocity time graph, for example, here it is here. This here represents u. Sorry, let me actually have it start here. This here represents u. And what does this here represent? V, good. What does this here represent? T. T. Now, this point here is 0u, and this point here is TV. And what's the slope? It's v, yeah, it's v minus u over t minus 0. That's the change in the velocity over the change in the time, which is also known as a. So the slope represents a. And finally, let's calculate what the area represents. So it's this distance, yeah. What is this unit here? The unit here is seconds. Yeah, yeah. And what's the unit here? Meters per second. So what's the unit here? What unit do you get when you multiply this with this? Meters. So if the unit is meters, then it must mean that the area represents S. Okay. So to summarize, U is the initial height, V is the final height, A is the slope, T is the base, and S is the area. So all the information is on the graph. Okay? I need you to make note of this. Yeah. Whoa, I did. Thank you. Final is usually spelled with one I, not two. Thank you. Yeah, no, that's not a new term. That should be final. Okay, you got that? No, okay. Got that? Yeah? Okay. I think this one is a bit too easy for you. Yeah, okay. This one here, we won't do it because it's a little bit too easy, I think. But I just, I got 59 seconds to plug the power in. Wow. Yeah, it's counting down now, isn't it? Which one of these is the computer? Oh.
Teacher, in your right hand side have more.
You're right, your left, your left.
That's okay. It's too late now.
35.
Yeah, no, I got it.
No.
Okay, there we go. We're fine. Right. So we won't do this one because it's a little bit straightforward. All I needed you to do was to plot these points. So you just go 0, 0, 1, 5, 2, 10, and so on. And how would you calculate the distance? The area of what you drew. And the acceleration? The slope up. And the deceleration? The slope down. Okay, it's a little bit too easy, I think. What I'd rather do together now, so I want to do this one together. A mass can accelerate at 5 and decelerate 6. The mass, the car, accelerates from rest and decelerates in 22 seconds. How far has the car travelled? So I'll draw the picture of what's happening. You have your car. It starts at rest. And accelerates and then decelerates. Okay? I tell you that this is a 5 and this one is going down at 6 meters per second squared. And the total time here is 22. Okay? And I want to know what is the distance traveled. What's the area? Okay, let's do this one together. So what I'll do is I'll make two triangles. And I'll just call this one here T1 and this base here, I'll call it T2. And what I'll do is I'll just mark off here, I'll call this V. Okay. Now, can somebody tell me what should 5 equal?
Equal
V divide T1. Because it's a slope. 5 equals V over T1. And what should 6? How did that happen? Weird. Okay, what should 6 equal? V over T2. No need for minus. The way I wrote it. Yeah. Okay? Yeah. So, can we get V and T1 and T2? No. There's not enough here, is there? How many unknowns are there? 3. T1, T2, and V. However, there's one more piece of information we know. T1 plus T2 equals 22. But T1 is V over 5. And what would be T2 if I use this? No, 6. Okay. Weird. T2 is V. I know, V over 6. Just by using this.
Okay.
Yeah? And that should equal 22. So you have 1/5 plus 1/6 V equals 22. So can someone calculate, please, what the V is? What is it? 60 exact meters per second. So the S, which equals the area, which will equal half the base, I'll get it now, times the height. Don't worry, I don't know why it's doing this. Maybe because I turned the computer off. It doesn't like that. Half the base by the height. Maybe it's just a bit loose. Steady. Ooh. It's not happy. It's not happy. I don't know what it is. Do I need to be in a certain position or something? Right, quickly, what's the base? Hang on. There we go. Whatever.
Oh. Just use that
Okay.
For you to
Okay, fine. Fine.
works now.
Right, what's the base? How bag's the base? 2. And the height? The height is 60.
Yeah.
So what's that? 660?
Yeah.
Is the answer. Yeah. Okay, I want you to write this down. Then after you write it, we actually got the lesson finished. So after you write this down, you can go. And don't forget you have homework for this as well. So you have the questions from the first class and now the questions from the second class. Okay? So write this down before it turns off and you can go then. Yeah. Yeah, that's from maths class. 5 is called the slope, and the slope is equal to the rise over the run, which means the vertical over the horizontal. Have you done slope? Yeah, we did slope, didn't we, in class?
Yeah.
I was going to say, did you do slope with your maths teacher, and then I remembered I'm your maths teacher. So I know you did slope. Did you write that down, Ming? Yeah, then you can go when you're ready. All right. Okay, let's close this.